Hey, this is Mr. Janes. In previous videos, we've talked about the properties of triangles and quadrilaterals by using reflections and rotations to determine which angles, sides, and diagonals are congruent to each other, how those correspond, how those parts match up. In this video, we'll start by reviewing that information using reflections and rotations to again show how different sides, angles, and diagonals correspond to each other. And then in the second half, we will go ahead and apply that information to find missing sides and missing angles in triangles and quadrilaterals. I'd like you to begin by pausing the video and trying to fill in the blanks in these 6 questions. The first 2 are about an isosceles triangle and a parallelogram. The next 2 are about a rectangle and a rhombus. And the last 2 are about a kite and an isosceles trapezoid. Again, please pause the video and try and fill in the blanks in these as best you can. The answers will be up in 3, 2, make sure you've tried these first. Alright, let's discuss the answer. The first question notes that an isosceles triangle is a reflection of 2 right triangles. Before I answer any questions, I'm going to mark any lines of symmetry or points of rotation with a yellow pen right here. I suggest you do the same thing with a highlighter for every question so you can see what's going on a little better. And this is a reflection of 2 right triangles. I'll put those right angles in right there. Alright, now that we can see that reflection from one side to the other, let's go ahead and answer some questions. RS, right here, is congruent to, well, by reflection, it's congruent to TS, right here, that side TS. And again, I'll put the line on top because it is a segment. And angle R, well, by reflection, it is congruent to angle T. And don't forget the angle symbol right there. Now, from this, we notice that in any isosceles triangle, these 2 angles right here, R and T, are called base angles. Okay? And base angles in an isosceles triangle are always congruent. So let's write that down as a little note. Base angles are congruent in an isosceles triangle. And that's those 2 angles right there that are across from these congruent sides that we talked about in the beginning. The next question says that a parallelogram is a rotation of 2 pairs of triangles. Well, let's look at exactly what that means. So I'm coloring in 2 triangles right here in red that are a rotation of each other, and these 2 triangles in green are also a rotation of each other. Okay, about point E right here. That means if I took this parallelogram and rotated it about point E 180 degrees, I would get the same parallelogram. That's what rotational symmetry means. This will help us when we're answering some of the questions, so let me just take these red and green colors and make them a little lighter. Now we can answer some questions. Start with BC. If I look at side BC here, put 1 mark on it, that would be congruent to, well, thinking about that 180 degree rotation, looks like it's going to be congruent to DA. DA. Okay. And BE, it's half of that diagonal right there. I'll put 2 marks on it. Thinking about 180 degree rotation, yeah, it'll be congruent to that diagonal DE. DE right there. What about angle CBE? Let's find where this angle is. Remember, we name angles with one side, so it's from C. B is the vertex, the middle letter, and then E is the other side. So this is the angle right here. So what is angle CBE going to be congruent to? Well, again, if I think about a rotation right here, that'll land me at this angle. And this angle is A, one side, D, the vertex, E, the other side. So angle ADE. Now we've just learned a few things out about parallelograms. The first one is that opposite sides are congruent. What I mean by that is these sides we talked about in purple, opposite sides, are congruent. And these sides here I'm marking in red are also congruent. Another thing we've learned is that the diagonals bisect each other. Remember, what I mean by that is that this diagonal here, highlighting green, okay, is cut in half by the other diagonal that I'll highlight here in blue. Right? So they cut each other in half so that they create 2 congruent halves. They're not the same length, but they do bisect each other. We've also learned that opposite angles are congruent. For example, this angle here and this angle here are congruent. Another way we could see that is because if we think back to our previous discussion about parallel lines and transversals, think of these 2 as parallel lines, and this line right here is our transversal cutting through the middle. Okay? That gives us that this angle here and this angle here are alternate interior angles, and so of course they're going to be congruent. Similarly, this whole angle here and this whole angle here, again opposite angles, will also be congruent in a parallelogram. Those are three important properties that will be important to remember for the other side of the sheet. Next up we have rectangles. A rectangle is a reflection of two pairs of isosceles triangles. So here are our lines of reflection. We've got one line right here, another line of reflection right here. Which means that this triangle right here, in green, is reflected over this line to form this triangle here in green. Or this triangle here in red is reflected over this line right here to form this triangle in red. Let's try and keep those ideas in mind as we answer the following questions. AR, right here, I'll put one mark on it, is congruent to, well, if we think about our reflection over this vertical line, it will be congruent to BR. If you think about reflections over this horizontal line, they'll both be congruent to DR and CR. So we've got AR is congruent to BR, CR, and DR. Great. Next, angle BAR, let's see here, one side BAR, so this angle right here, that angle right there, is congruent to, well again, we can reflect this over this vertical line to this angle, or we can reflect them both horizontally to get to these angles. And that makes sense because those angles we highlighted in red before are isosceles triangles, and the base angles in green should be congruent. So let's name those. This one would be RBA, angle RBA. This one, let's see, we call DCR, DCR. This one we call CDR, CDR. Perfect. Now, the important thing to remember about rectangles is that unlike any of the other quadrilaterals we have, the diagonals are congruent, meaning they don't just cut each other in half. In fact, all the diagonals, all four parts of those diagonals here, are exactly the same length. They're all congruent. That doesn't happen in just a regular parallelogram. Next, let's take a look at a rhombus. A rhombus is a reflection of four right triangles. So think of there being four right triangles, okay, and they're all reflected across these diagonals. Again, they're right triangles, so we've got this right angle in the middle. Now, hopefully we can answer some questions. Let's see, AB. AB is this length right here. I'll put it in green. Now, that's congruent to, well, all the other lengths. If I reflect it across this line, it's congruent to BC, or if I reflect those both across these lines, they're congruent to AD and CD. So we've got AB is congruent to BC, CD, and DA. Great. What about the angles? Well, here's angle BAE right here. So that's this angle right here. What will that be congruent to? Well, if I think about a reflection across this line right here, it's congruent to that angle. Or if I think about reflections across these lines, they will be congruent to these angles. So all four of those are congruent. Let's see if we can name them. This angle right here would be, let's see, DAE, angle DAE. This angle right here would be angle DCE, angle symbol DCE. And this angle here would be BCE, angle BCE. Let me fix that middle one really quick. Lastly, it asks about angle AEB, AEB, this angle right here. Now it has an equal sign, which means it's not looking for another congruent angle, it's looking for the measure of that angle. Well, we just talked about how this is four right triangles, so all of those will have to be 90 degrees each. I mean, that makes sense. 90 times 4 is 360, and we should all have 360. So it's a 90-degree angle. This leads us to an important fact about rhombuses. The diagonals of a rhombus are perpendicular. They'll always meet at a 90-degree angle, at a right angle. We've also learned that the diagonals bisect the interior angles, which means that this diagonal right here cuts this angle into two congruent parts. Same thing over here. This will be cut into two congruent parts, and two congruent parts. Finally, let's look at a kite and a trapezoid. This question tells us that a kite is a reflection of two pairs of right triangles. So here's our line of reflection. We've got one right triangle here and another right here that are being reflected down below to these two right triangles. Okay, and again, the right triangles, so 90-degree angles all around. Let's answer some questions. EK right here, well, that will be congruent to ET, again, by reflection. ET, don't forget the line on top. KS, this part of this diagonal will be congruent to, let's see, I would say TS, right there, again, by reflection. Let's get into some angles here. KES, over one side, KES, the vertex the other side, there it is. KES will be congruent to, again, using a little bit of reflection, let's see, TES, angle TES, and last but not least, angle EKS, that's, okay, this angle up here will be congruent to angle ETS, angle ETS, again by that reflection. So we've discovered a couple of things here. First off, we know that one pair of opposite angles are congruent. So this whole angle, right, this EKL, and this angle ETL right here will be congruent to each other, again, because they have that line of reflection, that symmetry going on here. On the other hand, these diagonals right here cut these angles in half, right? The diagonals bisect those angles, or cuts this angle in half as well. So it's a little bit weird how this works, right? We've got these two angles will be congruent, whereas these angles will be cut in half by the diagonals. Lastly, we know that the diagonals are perpendicular, again, because it's this reflection of those two right triangles. So it's kind of like a rhombus in a way, because a rhombus also has those perpendicular 90-degree diagonals. Last up, an isosceles triangle has reflective symmetry. So we've got this line right here of symmetry that this isosceles trapezoid has. Now, that can help us with some of these questions. For example, PT right here, I'll put one mark on, is congruent to RA. Okay? Again, it's got that reflective symmetry. So PT, I'm going to use AR right here. AR. Again, the line on top. Similarly, the diagonals, PD, let's see, it'll be congruent to AD, again, because of that reflection. AD, right there. Okay. Let's check out some angles here. So we got angle TPA right here. What will that be congruent to? Well, if I use a little bit of reflection, right here, that's congruent to angle RAP, angle RAP, RAP. And lastly, if I look at this angle up here, that's PTR, that'll be congruent to this angle here, which is ART, angle ART, angle ART, angle ART. Now this tells me that in any isosceles trapezoid, the base angles will be congruent. We call this side right here and this side PA right here, TR and PA, the bases of that trapezoid, and so these two angles, here and here, those base angles, are congruent. Or this angle and this angle right here, okay, those are base angles, those are also congruent. And one last thing we can notice here is that in an isosceles trapezoid, the diagonals are congruent. Now they don't cut each other in half, but this diagonal, this part and that part, will be congruent to this diagonal, that part and that part. Now, like I said, they don't cut each other in half, they don't bisect each other, which means that those two halves of the diagonal are not congruent. But as a whole, this diagonal is the same length as this diagonal, again, because of this reflective symmetry. I hope that you've understood a little bit more about triangles and quadrilaterals and the properties that they have using this activity. Be sure to rewind and pause if you need, and come to class with questions. I'll see you then.